Okay, so welcome back, and in this video we're going to do some examples of using the multiplication axiom to solve these equations here. So I'm going to show you multiple ways on some of these so you can see it in action. So here we go. So in this case here, oops, keep doing that. So in this case here we have 4x equals 48, and so we're multiplying by x here. So again, another way to think about this is you're going to do the opposite to both sides, right? So I have to undo the multiplication. There's a multiplication going on here, right? So I can undo the multiplication by using the inverse operation, the opposite operation, which is division. So if I want to undo this multiplication by 4, then I have to divide both sides by 4. So that's one way of looking at it. So I can do this by, again, dividing both sides by the coefficient attached to the x variable. So I'm multiplying the x by 4, so I'm going to divide both sides by 4. 4 divided by 4 is 1, so I get x equals 48 divided by 4, which is 12. So x equals 12. Okay? Now, what about this one here? Well, the coefficient is 0.5, right? So I'm multiplying, and what I'm basically doing is I'm taking x times 0.5. That's what the coefficient means. It's a factor. Remember from the previous videos, these are factors of each other. So the opposite of multiplication is going to be division. So I'm going to divide both sides by 0.5. And so what do I get? Well, in this case, I get 90 equals x, or x equals 90. Again, remember the symmetry principle. Okay, it doesn't really matter. I can write it as x equals 90. Okay? So again, I'm just using the addition principle. So, oh, by the way, just for completeness, so if I have a, if I have a equals b, right? So if I use the multiplication principle with division, then it also means that if I divide both sides by the same non-zero quantity, then it still conserves the equality. Okay? I showed it for the multiplication, but again, it holds for division as well. Okay, so now in this example here, I've got negative n equals 27. Now remember, this is the same as if I wrote it negative 1 times n equals 27. Okay? So again, so in this case, I'm going to divide both sides by negative 1. And so again, I get n equals negative 27. Okay? So again, remember, I want a positive 1 over here. Okay, and finally, this one. Now here, any one of these I could have done using a different one, but I'm going to demonstrate using this one. Okay? So here's what I'm going to do. I'm going to divide both sides by what I'm doing. So again, using what I've been doing, I'm taking 1/4 times n equals 7. So if I do the opposite, then I'm going to divide both sides by the coefficient, right? So I'm going to divide both sides by 1/4. So 1/4 divided by 1/4 is 1, so that gives me n equals 7 divided by 1/4. But then I can use the other principles we've learned, and I can change this to a multiplication where I'm saying this is 7 times the reciprocal of the bottom, which is 4 over 1, or just 4, right? And then sometimes 4 is 28, so I get n equals 28. as my answer, right? Now, I could have also solved it another way. So again, instead of dividing both sides by the coefficient, I can multiply both sides by the reciprocal of the coefficient. So in this case here, I could take 1/4 n, multiply it by the reciprocal of 1/4, which is 4 over 1, and then whatever I do to one side, I have to do to the other side, so I'm going to multiply 7 by 4 over 1. Okay? So here I get 4 times a fourth, which is 1. And over here I get 7 times 4, which is 28. Okay? So either way, remember, so I can either multiply both sides by the reciprocal of the coefficient, or I can divide both sides by the coefficient of the variable term. Okay? So either way will work, as you can see. Okay, have a great day. See you next time.